guys, Connor here. Today I'm going to be showing you how to make a very basic system monitoring application in C#, which will be able to monitor network bandwidth, CPU usage, and memory usage with alerts once we reach a certain threshold. Now we want to create a new project. This will be a console app. Call it System Monitor. And we'll just use .NET 6, and I'm going to tick do not use top level statements. Okay, so now that has been created, before we start working on the main features of the application, we need to create 3 separate threads so the code can run at the same time as each other. So we'll go create a new thread, bandwidth monitor thread equals new thread, and here we'll just go private static void bandwidth monitor. We'll bandwidth monitor, put the method in there, and we will call start. So if we just put a basic hello from the bandwidth monitoring thread. So now if we run this, you can see we've got this here, but it closes, which we don't want. So simply just do thread.sleep -1, and that will prevent the application from closing until we close it ourselves using the close button or just Control-C. So we need to do this 2 more times. Memory monitor thread, new thread, call start on that, private static void memory monitor, and we'll put a method in there, and then we will do CPU usage monitor thread, CPU monitor, and then start on that as well, CPU monitor, and then we'll just output hello from the CPU monitor, and from here hello from the memory monitor. So now if we run this, there we go. So we have 3 threads running in the background whilst our application remains open. So now let's move on to the first part. So the first part in the application is to set up bandwidth monitoring. So in this thread we will need to get a list of interfaces, network interface, get all network interfaces. Then we will old bytes sent 0, old bytes received equals 0. They're just variables they'll be using further on in the code. So while true, we need start time, date time now. So while true, new bytes sent equals 0. These can be var actually. New bytes received equals 0. So now we need the elapsed time, date time dot now minus start time, and then we need to iterate over each network interface. Statistics is network interface get IPv4 statistics, and new bytes sent, we're going to add statistics dot bytes sent, and the same for received. Okay, so we've got an error. We just need to convert these to longs. So just add L in front of each of them to tell us it's a long. So now we've got the amount of bytes received. We need to calculate the send speed in megabits per second. So for this, we will go var send speed is new bytes sent minus old bytes sent times by 8, and then divide that by elapsed time dot total seconds times by 1 million. And then same thing for the received, but obviously replacing receive speed new bytes received minus old bytes received times by 8 divided by elapsed time total seconds times by 1 million. Okay, so we've got the receive and send speeds. Let me just get rid of these useless parentheses. So now we just simply need to console write line send speed will be 0 Mbps. So send speed to string, and then we need to force it into that. So that will become, say for example, we're using 15 megabits a second. It'll become, we'll make, so basically that. We need to do the same thing for receive speed. Receive speed to string, and then make it have 2 decimal places. So now, once we've done that, old bytes sent equals new bytes sent, old bytes received, new bytes received, and start time equals now. And then we need to add our thread.sleep for 1 second. You don't need the underscore there, but I just add it for clarity. Okay, we run this now. There we go. It will say a weird amount initially, but as you can see, so now if I run a speed test with this open, click go, you should see on the side that the send speed and receive speed will go up. There we go. Receive speed 69 megabits a second. And now for the upload, similarly, it shows 18, which is near enough what it shows on here. And then once we close that, it goes back to normal. Now, the second part in our application is CPU usage monitoring. So, in our CPU monitor thread, we need to also have a while true, but first we need a using var CPU counter performance counter, and then we need to install the diagnostics package. There we go. So category name will be processor, the counter name percentage processor time, and the instance name is underscore total. Now what this is doing is creating an instance of CPU counter that when it goes out of the method will be disposed. It's the equivalent of using var blah blah within there, so you can define a scope, but the scope that we need is just for the method, so we can do this to simplify it. Now that we've got the performance counter, we need to while true, CPU usage equals CPU counter next value. Simple as that. CPU usage is CPU usage. And then thread.sleep 1 second. So now if we run this, okay, so overall 33%, yeah, it's showing the right values. Now that we've done that, we just start it. CPU usage 27%. Then you should see the CPU usage shoots up. Okay, so now it's loaded. We'll go to bench and we'll just bench CPU. And as you can see, CPU usage has gone to 100%. I'm just going to stop that. But yeah, so as you can see, CPU usage shot up to 100% whilst we were doing that. So that's working. Now, the last part of our monitors is memory monitoring, which will basically just show the amount of 3 gigabytes your system has. What we need is another performance counter, memory counter. Instant category name is memory. The category name is memory. The counter name is available bytes. So now, while true again, long. So this will be a long. So while true again, available memory bytes equals long memory counter next value. So now available memory GB is available memory bytes divided by 1024 times 1024 times 1024 times 1024. No, I do not need that last part. So that converts from bytes to kilobytes to megabytes to gigabytes. Okay, so now we need to print it out. So this will just be available memory GB F2 GB. Okay. So now if we start this, we can see this. And that's what happens if you don't put your memory sleep. Your thread sleep, even. There we go. Okay, there we go. So now if I create a RAM disk with 4 gigabytes, there we go. Available memory has gone down. But now if I unmount it, memory's gone back up. So now we can set up alerts on each of our threads to show a Windows pop-up just at the bottom of the screen here when one of the usages reaches a certain threshold. So to do this, we need to add a NuGet package, and it'll be Microsoft.toolkit uwp.notification. So if you install this, click I accept. Okay, so now that we've got that package installed, we need to go to properties. We need to then target OS Windows. Target OS version needs to be 17763 or greater. So if we'll add that. So now we'll start off with the memory monitor. trigger an alert if available memory goes below 30 gigabytes. If available memory GB is less than 30, then we'll go new toast content builder, add text, warning, available memory is now below 30 gigabytes, and then dot show. So now, if we start this, we can see available memory is 32 gigabytes. If I do another RAM disk for 10 gigabytes, we should see a little pop-up. There we go. So all we need to simply do now is replicate that across the CPU usage and bandwidth monitoring. Of course, you will receive one of these every single second, but that can easily be sorted out just by private static bool memory monitor alert shown equals false, and then we will go memory equals that equals true. If memory monitor alert is not shown, then we can just show that. Otherwise, we can just set that to false. So now we should only receive one alert. So we'll do the same for CPU usage monitor alert shown equals false. If CPU usage is greater than or equal to 30%, greater than 30% CPU. So then, if CPU thing hasn't been shown, new toast content builder, toast content, new toast content builder, add text, warning, CPU usage is above 30%. And then we'll set that to true, otherwise set that to false. Okay, so now close the RAM disk. CPU usage is 19 now. So if we see the value here, you can see it is in this format. Okay, so if I run the benchmark again, okay, so I'll do a benchmark. Okay, so we're getting 100%, and I forgot to add the dot show. Okay, so if we bench CPU, we only get this once. There we go. So now it's returned back to normal, and we are not being spammed with notifications. So now the last one is static bool. There we go. See, it's still working. Bandwidth monitor alert shown equals false. So now if send speed is greater than say 60 megabits a second, then we want to show. We can just copy this just to prevent typing it out again. But obviously changing the bandwidth. Download bandwidth. Download speed is over 60 Mbps. And receive speed. Okay, so actually let's do the same for send speed. Receive speed alert shown. So now we'll add another boolean. Send speed alert shown. So now we can just copy this and change a couple of values. I'll do 15 megabits a second for this one. Upload speed is over 15 megabits a second. And if send speed alert is not shown, we will set it to shown. Otherwise, we'll set it to false, which we also need to do here. Okay, so now this should be a basically fully functional monitoring system. You will get the notification due to a bit of weirdness. But now, if I run another speed test, CPU usage alert has gone off again. Here, download speed is over 60 megabits a second, which it is. CPU usage is also above 30. Now the upload speed is over 15 megabits a second. The only reason I'm getting these alerts is because I've just set the CPU threshold to 30, which is a bit too low. Now that we have all of that finished, our application is finished and ready to be used. Of course, I encourage you to tweak this to your liking and add and remove features as you please. So, thanks for watching. If you enjoyed, make sure to rate, comment and subscribe. Bye.